Welcome back. Hopefully you just finished the exercise practicing rewriting the system of second-order differential equations as a matrix vector product. You should have ended up with something of this form. Let's have a look at this system of differential equations. Can we somehow simplify this a little bit? If x were an eigenvector, then A times x would be equal to lambda times x, where lambda is its eigenvalue. This would indeed make the entire system a lot easier to solve. We would end up with a system of equations with on the left-hand side the second derivatives of the displacements and on the right-hand side a multiple of that same displacement. What would the solution of such an equation look like? Let's first look at a similar but simpler problem. The equation y double prime equals a squared times y. Maybe you have already seen how to solve such an equation in a calculus course, but we will try to figure out here what the solution of this equation should be. First, which function y of t becomes a multiple of itself after differentiating twice? Well, the exponential function, of course. If y is equal to e to the power a times t, then, because of the chain rule, the derivative is equal to a times the original function. If we differentiate 2 times, we get a squared times the original exponential function. This leads us to believe that the solution that we are looking for in our mass spring model must be of the same form. We will assume that the vector x that we are looking for is of the form v times an exponential function. In this case, we will not use a factor a in the exponent, but I times omega, since the solutions of our system of differential equations could be complex. When we take the second derivative of x, we obtain minus omega squared times the original vector. You might wonder where the minus sign comes from, but this is actually the square of the imaginary number I. We now have two expressions that are both equal to the second derivative of the vector x. If we equate them, we obtain that a times x must be equal to minus omega squared times x. This reminds us of the definition of an eigenvector. The minus omega squared is in fact an eigenvalue of a. In the exercise for this video, you will compute the eigenvalues of a and use them to solve the system of differential equations that describes our mass spring model.